Hi there. So in this video, we're going to talk about graphing quadratic functions. So as you recall, a quadratic function is of this form: ax squared plus bx plus c, where a, b, and c are just numbers, and the a can't be equal to 0 because you got to have that square term. A quadratic function, when it's graphed, should always look like a parabola. It can be a parabola facing upward, like you see in the graph on the left, or it could be a parabola facing downward, like you see the two graphs over on the right. So let's talk about some key elements of quadratic graphs, okay? So starting here in example 1, it wants us to use these graphs to identify the pieces underneath, okay? So I'm going to do the first and second one with you and let you try the third one, okay? So the axis of symmetry is the line that cuts that parabola right in half, okay? And the axis of symmetry you should find should always run through your vertex, and that vertex is either going to be a maximum or minimum point. We'll talk more about that in just a moment, but I'm going to try to, yeah, there we go. That looks pretty good. So this would be referred to as my axis of symmetry. Axis of symmetry then is always going to be of the form x equals, and then the x value that it runs through, and it's running through 5. So x equals 5. Then it wants to know, well, what's the vertex? And so the vertex is, like I said, that bottommost point of the parabola or the topmost point. In this case here, we're talking about this point right here. So the ordered pair there would be 5, -4. Then it's asking, is that vertex a maximum or a minimum? And so hopefully you agree here, that is the lowest point on that graph, so it is a minimum. X-intercepts, where do I cross the x-axis? I cross the x-axis in 2 spots, here at 3 and at 7. So I'll write those. I have x-intercepts at 3 and 7. Y-intercept, where do I cross the y-axis? And I'm coming over here, I'm crossing the y-axis, and I'd say it's just a little bit above that 20. So I'd probably guesstimate it to be about 22. Okay. All right, let's move over to B. And letter B, it wants to know, what's your axis of symmetry? What would be the line that would cut this right in half? And you would agree, this line right here, that'd be cutting it right in half. So that would be the line at x equals what kind of 2? -2. So axis of symmetry is always going to be x equals and then some number, and it should always be the x value of your vertex. So then my vertex, I want to put an ordered pair to this one, so we know that's going to happen at -2, -8. Is that vertex a maximum or a minimum? If you trace this graph, that happens to be the highest point on the graph, so that is a maximum. X-intercepts, where do you cross the x-axis? In this graph, I don't cross the x-axis anywhere, so there are no x-intercepts. Y-intercept, I am crossing the y-axis, though, right here at -12. Okay, I'll let you pause the video and try the last graph on the right to make sure you feel good with this. You'll notice I had a little question down here below, and it says, how many x-intercepts is it possible for the graph of a quadratic function to have? And I've been hesitant to mention this in a previous video, but if you're raised to the second power, the maximum number of x-intercepts that you can have is 2. All right, so x squared, that degree is 2, so the maximum you can have is 2. All right. If you don't have a graph given, you can still get a lot of the information that we just identified from some of our prior knowledge, and we're going to pick up some new knowledge as well, okay? From the equation itself, we will be able to determine whether our parabola opens up or down. And just by, and you look at the leading term on that x squared term, if your a is positive, you open up. If your a is negative, you open down. So hopefully that just makes sense to you, that when a is positive, we're going to open up. When a is negative, we're going to open down. So very intuitive there. So what I have you do down below in example 2 is I say, well, let's look at those graphs from above, and let's determine if the leading coefficients on those were either positive or negative. So I'm going to think of this as A, here's the middle one, and then there's C. I'm looking at the graphs above there. Now the equations weren't given to us, I don't believe. No, I didn't give you the equation, I just gave you the graph. And what I'm asking you here, looking back at the very first graph, this graph is opening up. So here I would say that it opens up, so that means our A value then had to be positive, okay? Versus B, my graph is opening down, so I'll write here, opens down. So in this case, then my A had to be a negative value. Okay, so I'll let you repeat that there with letter C, or example C there. And then I'm going to flip it over to the next page. If we don't have a graph sitting in front of us, we can still find all of those pieces that we were just talking about. Our x-intercepts, our y-intercepts, the axis of symmetry, the vertex, all of that can be found. The axis of symmetry, the equation for that is x equals opposite b over 2a. So to find the equation of our axis of symmetry for this function right here, I just throw it into my equation. And remember, a, b, and c. So opposite b, so that b is 6, so opposite b would be negative 6 over 2 times a, so 2 times 1. Negative 6 divided by 2, that gives me negative 3. So my axis of symmetry, I'm just going to abbreviate there as AOS, is the line x equals negative 3. That'd be our final answer. Okay. Now the vertex can be found utilizing the formula given below, and essentially it builds off of that formula for the axis of symmetry. It takes that opposite b over 2a and says, okay, now you take that value, plug it into the function, and that's going to give you the y value of your vertex. So what I did down below here in example 4 is I used the exact same equation as above, and I said, let's find the vertex. So looking for my vertex here, I'm just going to repeat, but to find the x, it is always the same as whenever you found your axis of symmetry. It's opposite b over 2a. So that's going to be negative 6 over 2 times 1. Negative 6 divided by 2, so negative 3. Then to find y, you go to the equation, and everywhere you see an x, you're going to plug in negative 3. So negative 3 squared plus 6 times negative 3 minus 7. Do all of that, and you should land at negative 16. So that tells me then that I have a vertex here at negative 3, negative 16. There's my vertex. Personally, I always like to find the vertex first, and then once you've found the vertex, your axis of symmetry is always x equals, and it's the x value of the vertex. Okay, so that's what you'll see me, as we move forward in this section, you'll see me kind of move to that format. Now, below here in example 5, I want to revisit finding x and y intercepts, okay? So remember, to find your x-intercepts, we let y equal 0 and we solve for x. To find your y-intercepts, we let x equal 0 and solve for y. Because remember, a y-intercept is always of the form you're trying to solve for the y. X-intercept, you're trying to solve for the x, and you're letting y equal 0, okay? So we'll first do the y-intercept here. So that says everywhere I see, go to my function here, everywhere I see a x, I'm going to plug in 0. So y equals 0 squared plus 6 times 0 minus 7. So all that 0 just cancels out. Negative 7. So I'm going to cross the y-axis at negative 7. X-intercepts, I'm going to let y equal 0. So x squared plus 6x minus 7 equal to 0. We'll try to factor. We'll always try to factor first. So x and x. The only way to multiply to give you 7. 7 times 1. We want a positive 6 in the center, so hopefully you agree I need 7 positive and 1 negative. Set both of those equal to 0 and solve for x. So if we set this equal to 0, we get x equals a negative 7. Solve for this one, we get x equals a positive 1. So we have x-intercepts at positive 1 and negative 7. So I've got 2 x-intercepts. The vertex we found just a minute ago, up above, that was our negative 3, negative 16. Okay, so I'm just copying that down. And then our axis of symmetry, we found that above, and that was x equals negative 3. The only thing else I'll talk about here is even before we graph it, is this parabola going to open up or down? And so you remember, you look at the leading term there. It's always as long as you got it in descending order, look at that leading term. If it's positive, you open up. If it's negative, you open down. So since this is positive, this one is going to open up. Okay, so let's plot these pieces here on the graph over on the right. Let's make sure that it does indeed do that. So pen going here. I'm going to plot my y-intercept at negative 7. X-intercepts at 1 and -7. And I've got a vertex at -3, -16. All right, I'm going to try to sketch this out. I'll pass through that. Here we go. And then I'll try to put in that axis of symmetry as well. Axis of symmetry is running right here at x equals -3, cutting it right in half. Think about folding it over. I'll put AOS there, axis of symmetry. X equals -3. If you folded it over, it would be directly on top of each other, okay? All right, so I'm going to flip it over. In example 6, basically in example 6, you're repeating the process of finding axis of symmetry, vertex, your intercepts. I am going to come down, I'm going to do letter C with you, okay? And I think that there's by me doing letter C is, this page is essentially just like we got finished doing in example 5. So I'm going to let you do A and B on your own. We'll come down here to letter C and do this one together. All right, so if I'm thinking about, the order that I would typically do this in is, let's find our vertex first. All right, so vertex x value is opposite b over 2a. So remember A, B, and C. So opposite b, that's going to give me a +4 over 2 times -1. 4 divided by -2 will give you -2. So I'm going to come over here, I'm going to identify my vertex then. I know x is -2. To find the y value, go to your function. Everywhere you see an x, plug in -2. So I have -2 squared minus 4 times -2 minus 12. So -2 squared is going to give me 4. Then well, I'll just let you pop this in your calculator because it would give you +4. Then the negative on the outside would make it -4 plus 8 minus 12. That should land you at -8. So I've got a vertex at -2, -8. From that, the axis of symmetry just falls out. It's always x equals, and it's the x value of your vertex. So x equals -2. All right, so that's done. All right, so now let's do which way it's going to open. Opens up or down. Since that leading term here is negative, it is going to open down. All right, next thing we need are x-intercepts and y-intercepts. All right, those are the last few things that we need. All right, so let's start with x-intercepts. Remember, x-intercepts, you're trying to solve for x, so you're letting y equal 0, so I'm taking my function here, -x squared minus 4x minus 12, setting it equal to 0. Now, we've talked about this before. It's easiest to factor when the leading term is positive, so I can factor out a -1. X squared plus 4x plus 12 equal to 0. Now, if I try to factor x and x, 6 times 2 will give me 12, and I can get +4 out of that. I'd have to make 6 positive and 2 negative. The problem with that, though, is that 6 times -2 gives me a -12, and I got a +12 there. There's no other way then to factor, so this will not factor. If you can't factor, what do you use? We agree, quadratic formula. So opposite, remember A, B, and C. So opposite B, -4 plus or minus square root b squared minus 4 times A times C all over 2A. That's going to give me -4 plus or minus the square root of 16 minus 48 all over 2. I'll burn one more step here. I get -4 plus or minus the square root of -32. All right, so from here, you get a negative underneath the square root. You're not going to get any real x-intercepts. So for x-intercepts here, then I have none. Because that, I cannot take the square root of a negative number. They would be imaginary. So no x-intercepts. Let's go to y-intercepts. Everywhere, remember for the y-intercept, everywhere you see an x, you plug in 0 because you're trying to solve for your y. So I can go back to my original equation. Everywhere I see an x, I'm plugging in 0. So all of this just goes away because it's multiplying times 0, and I'm left with negative 12. So that's my y-intercept. All right, so now let's plot these pieces. I've got a vertex at negative 2, negative 8. And I have a y-intercept at negative 12. And that is all that I have, other than the fact that I do have my axis of symmetry, but and we know that it opens down, so kind of looks something like this. I knew that it wasn't going to cross the x-axis, so I don't have any x-intercepts. And then there's my axis of symmetry at x equals negative 2. Okay. All right, I'll let you repeat some of those same processes, that same process there to wrap up A and B and check yourself by the solution key. And then I'm going to flip it over to the last page and try example 7 with you. This is a good foreshadowing here in example 7 for your types of problems that you'll move along into in Math 171 pre-calculus. So here in example 7, it says that standing on the roof of a building, you toss a ball upward. The height of the ball after x seconds is given by this function. Part A wants you to find the y-intercept of your function. Okay, so remember y-intercept, trying to solve for y, plugging 0 in for x. So negative 16, 0 squared, plus 80 times 0, plus 96. Well, we know all that's going to zero out. I'm just going to have 96 left over, okay? So think about, our ordered pairs here. You have x and h of x. So this is your x and this is your h of x. So this is your x represents time. So this is your seconds, and h of x is your height. So essentially what it's telling you then is that the ball was initially dropped from a height of 96 feet. So the ball was initially dropped from a height of 96 feet. Okay. Part B wants us to find the x-intercepts. So x-intercepts is where we set, trying to solve for x, and we let y equal 0. This time we're letting our height equal 0. So we're setting negative 16. Just come over here. I'm just going to negative 16x squared plus 80x plus 96, setting that equal to 0, trying to solve for x. All right, first thing I'm going to do here is I want that leading term to be positive. So I'm going to pull out a negative, but it just so happens that 16 will go into all of those numbers. So I'm going to pull out a negative 16 and write what I have left over. So x squared minus 5x minus 6. All right, so then let's see if we can't factor this. X and x. You got a couple ways to multiply to give you 6. Let's go with 6 and 1 though, because we want to get a, actually, let me do it wrong first just so you can see, because 3 and 2 will give you 6. And it'll also give you 5. So let's see, on the outside and inside, I got 2x and 3x. So let's do that, 2x and 3x. I want to get a negative 5. I can do that. I'd have to make them both negative. This is why I always encourage you to do that last double check. Negative 3 times negative 2 gives you a positive 6. So while you're getting the negative 5 in the center, you're not getting the positive 6 at the end. So 3 and 2 won't work. Swapping it's not going to do me any good. Another way to multiply to give me 6. 6 and 1. All right, outside and inside, I got 1x and 6x. My goal is a negative 5x. I can get that. I need to make which one negative? Totally agree. I need to make 6 negative. And then it checks. Negative 6 times 1 gives me my negative 6. Now I set every term that has a letter with it equal to 0. So I don't need to set negative 16 equal to 0. It doesn't have a letter. But I need to set x minus 6 equal to 0 and x plus 1 equal to 0. Solve for x in both cases. So here we should get a positive 6. And there we should get a negative 1. X represents time in seconds, so remember this is seconds, and this is seconds. So negative 1 second doesn't mean anything. X equals 6 seconds is our only answer here. It wants us to interpret the meaning here. So essentially it's saying that the ball has a height. The ball has a height of 0 feet at negative 1 second and 6 seconds. Or you could also say here that the ball hit the ground after 6 seconds. So the ball hits the ground after 6 seconds. Because again, that -1 seconds does not make any sense because we're talking about time. Part C wants us to find the vertex and interpret its meaning. So to find my vertex, x equals opposite b over 2a. So opposite b, -80 over 2 times a, so 2 times -16. So -80 divided by -32, that'll give me 2.5. Then I need to find my height at 2.5. So go to my function, everywhere I see an x, plug in 2.5. Clean that up and you should land at 196 feet because that's your height. So we're getting a vertex at 2.5, 196. This is your time in seconds. This is your height. Pretty sure we were feet, but let me go back and double check. You know what? It didn't say, did it? Standing on the roof of the building, you toss the ball where the height of the ball after X seconds is given by this. It's not jumping out at me here. I'm assuming feet, but I don't think I'm not seeing it there, you know, and I don't want to take up too much time here in the video. So what that means then is that at 2.5 seconds, the ball reaches its maximum height, because this is your vertex, of 196 feet. So the ball reaches its max height of 196 feet at 2.5 seconds. And then lastly, in part D, it wants us to take a moment and graph all of this information. So along the x-axis, we're measuring time in seconds. And on the y-axis here, we're measuring height in feet. So time, I can just measure, count by ones. 4, 5, 6, 7, 8 seconds. That should be plenty enough. I'm going to count by 20s here on the y-axis. So 20, 40. We know its max height is 196, so getting up to 200 is good. All right, so y-intercept, we found that in the first part, and that was 96. So roughly, get a different color here for us. Roughly about right in here for 96. It told it we had a vertex at 2.5, right? 2.5, 196. So roughly about right in there. And the ball hit the ground after 6 seconds. So this sort of follows the trajectory of that ball. Like so. That here's my initial height. It traveled up, 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 up until it reached its maximum height, and then it came back down, and at 6 seconds, we found just a few minutes ago, that's whenever it was hitting the ground. All right, that finishes up this section. Thanks a lot. Bye.